Hello friends, I am your maths faculty from QLS Academy. We are going to continue with our topic areas related to circles in this session. Let us dive into the video. So we will start with a problem. Now unless stated otherwise, we have to use pi is equal to 22/7 in the problems. Now our first problem says that find the area of a sector of a circle with radius 6 centimeters if angle of the sector is 60 degree. So we know that area of the sector making angle theta is equal to theta by 360 into pi r square. So area of the sector making angle 60 degree will be 60 by 360 into pi r square centimeter square. That is equal to 1 by 6 into pi into 6 square, that is 6 into 22/7 centimeter square, that is equal to 132/7 centimeter square. Now our second problem says that find the area of a quadrant of a circle whose circumference is 22 centimeter. Now quadrant of a circle means sector is making angle 90 degree. Circumference of the circle is equal to 2 pi r, that is equal to 22/7, it is given to us. Now radius of the circle is equal to r, that is 22 by 2 pi centimeter, that is equal to 7 by 2 centimeter. Now area of the sector making angle 90 degree is equal to 90 by 360 into pi into r square centimeter square, that is equal to 1 by 4 into 7 by 2 square into pi, that is 49 by 16 pi centimeter square or 77 by 8 centimeter square. Now our next problem says that the length of the minute hand of a clock is 14 centimeters. Now we have to find the area swept by the minute hand in 5 minutes. So here minute hand of clock acts as radius of the circle. Therefore radius of the circle r is equal to 14 centimeters. Now angle rotated by minute hand in 1 hour is equal to 360 degree. Therefore angle rotated by minute hand in 5 minutes will be 360 into 5 by 60, that is 30 degrees. So area of the sector making angle 30 degree will be equal to 30 by 360 into pi into r square centimeter square, which can be written as 1 by 12 into 14 square into pi, which is equal to 196 by 12 pi centimeter square, that is equal to 154 by 3 centimeter square. So we get that area swept by the minute hand in 5 minutes is equal to 154 by 3 centimeter square. Now the next problem says that a chord of a circle of radius 10 centimeter subtends a right angle at the center. We have to find the area of the corresponding minor segment and the major sector, and in this question we have to use pi is equal to 3.14. Now radius of the circle is equal to 10 centimeter. Major segment is making 360 degree minus 90, that is equal to 270 degrees. So area of the sector making angle 270 degrees will be equal to 270 by 360 into pi r square, which is equal to 3 by 4 into 10 square into pi, that is 75 pi centimeter square, which is equal to 75 into 3.14 centimeter square, that is 235.5 centimeter squares. Therefore area of the major segment is equal to 235.5 centimeter square. Now height of triangle AOB is equal to OA, that is 10 centimeters. Base of the triangle AOB is equal to OB, that is again 10 centimeter. Now area of triangle AOB is equal to 1 by 2 into OA into OB, that is equal to 1 by 2 into 10 into 10, that is equal to 50 centimeter square. So major segment is making 90 degrees. Area of the sector making angle 90 degree will be equal to 90 by 360 into pi r square, that is 1 by 4 into pi into 10 square, that is 25 pi centimeter square or 78.5 centimeter square. So area of the minor segment will be equal to area of the sector making angle 90 degree minus area of triangle AOB, that is equal to 78.5 centimeter square minus 50 centimeter square, that is 28.5 centimeter square. Now our next problem says that in a circle of radius 21 centimeter, an arc subtends an angle of 60 degree at the center. We have to find number 1 the length of the arc, number 2 area of the sector formed by the arc, and number 3, area of the segment formed by the corresponding chord. Now radius of the circle is given 21 centimeters. So for the first part of the problem we have length of the arc AB is equal to theta by 360 into 2 pi r, that is 60 by 360 into 2 into 22 by 7 into 21, that is equal to 1 by 6 into 2 into 22 by 7 into 21, that is 22. So the length of the arc is 22 centimeters. Now for the second part of the problem, angle subtended by the arc is equal to 60 degree. Now we know that area of the sector making angle 60 degree will be equal to 60 by 360 into pi r square centimeter square, that is equal to 1 by 6 into pi into 21 square, that is 231 centimeter square. So area of the sector formed by the arc is 231 centimeter square. Now for the third part of the problem, area of equilateral triangle AOB will be equal to root 3 by 4 into OA square, that is equal to root 3 by 4 into 21 square, that is 441 root 3 by 4 centimeter square. So area of the segment formed by the corresponding chord will be equal to area of the sector formed by the arc minus area of equilateral triangle AOB, that is 231 centimeter square minus 441 root 3 by 4 centimeter square. Now our next problem says that a chord of a circle of radius 15 centimeter subtends an angle of 60 degree at the center. We have to find the areas of the corresponding minor and major segments of the circle, and we have to use pi is equal to 3.14 and root 3 is equal to 1.73. Now radius of the circle is given as 15 centimeters. Triangle AOB is isosceles as two sides are equal. Therefore angle A will be equal to angle B. Now sum of all angles of a triangle is equal to 180 degree. Therefore angle A plus angle B plus angle C will be equal to 180 degree. Now 2 into angle A will be equal to 180 minus 60. Therefore we get angle A is equal to 60 degree. So the triangle is equilateral as angle A is equal to angle B is equal to angle C, that is 60 degree. Therefore OA is equal to OB is equal to AB, that is 15 centimeters. Now area of equilateral triangle AOB is equal to root 3 by 4 into OA square, that is equal to root 3 by 4 into 15 square, which is equal to 97.3 centimeter square. Now angle subtended at the center by minor segment is equal to 60 degree. So area of minor sector making angle 60 degree will be equal to 60 by 360 into pi r square, that is equal to 1 by 6 into pi into 15 square, that is 225 by 6 pi centimeter square or 117.75 centimeter square. Now area of the minor segment is equal to area of minor sector minus area of equilateral triangle AOB, which can be written as 117.75 centimeter square minus 97.3 centimeter square, that is 20.4 centimeter square. Now angle made by major sector is equal to 360 minus 60, that is equal to 300 degrees. Now area of the sector making angle 300 degree will be equal to 300 by 360 into pi r square, that is 5 by 6 into pi into 15 square, which is equal to 588.75 centimeter square. Now area of major segment is equal to area of minor sector plus area of equilateral triangle AOB, which is equal to 588.75 centimeter square plus 97.3 centimeter squares, that is 686.05 centimeter square. Now our next problem says that a chord of a circle of radius 12 centimeter subtends an angle of 120 degrees at the center. We have to find the area of the corresponding segment of the circle, and again we have to use pi is equal to 3.14 and root 3 is equal to 1.73. So radius of the circle is given as r is equal to 12 centimeter. We have to draw a perpendicular OD to chord AB. It will bisect AB. So we get angle A is equal to 180 degrees minus 90 plus 60, that is equal to 30 degree. Now cos 30 degree is equal to AD by OA, which gives us root 3 by 2 is equal to AD by 12, since we know OA is equal to 12. Therefore, AD is equal to 6 root 3 centimeter, which gives us AB is equal to 2 into AD, that is 12 root 3 centimeter. Now, sin 30 is equal to OD by OA. So, we can write 1 by 2 is equal to OD by 12. So, from this we get OD is equal to 6 centimeter. Now, area of triangle AOB is equal to half base into height, which is equal to half into 12 root 3 into 6, that is 36 root 3 centimeter, which is equal to 62.28 centimeter square. Now, angle made by minor sector is equal to 120 degree. So, area of the sector making angle 120 degree is equal to 120 by 360 into pi r square, which is equal to 1 by 3 into pi into 12 square centimeter square, which gives us finally 150.72 centimeter square. Therefore, area of the corresponding minor segment is equal to area of the minor sector minus area of triangle AOB, which is equal to 150.72 minus 62.28 centimeter square, that is 88.44 centimeter square. Now, our next problem says that a horse is tied to a peg at one corner of a square shaped grass field of side 15 meters by means of a 5 meter long rope, as you can see in the figure. We have to find number 1, the area of that part of the field in which the horse can graze. Number 2, the increase in the grazing area if the rope were 10 meter long instead of 5 meter. Again, we have to use pi is equal to 3.14. Now, for the solution, side of the square field is equal to 15 meter. Length of the rope is the radius of the circle, r is equal to 5 meter. Since the horse is tied at one end of square field, it will graze only quarter of the field with radius is equal to 5 meter. So, for first part of the problem, area of circle is equal to pi r square, that is 3.14 into 5 square, that is 78.5 meter square. Now, area of that part of the field in which the horse can graze will be equal to 1 by 4 of the area of the circle. So, that is equal to 78.5 divided by 4, that is 19.625 meter square. Now, for the second part of the problem, area of circle if the length of rope is increased to 10 meters will be equal to pi r square equal to 3.14 into 10 square, which is equal to 314 meters square. Therefore, area of that part of the field in which the horse can graze will be equal to 1 by 4 of area of the circle, that is equal to 314 by 4 or 78.5 meters square. Therefore, increase in grazing area will be equal to 78.5 meters square minus 19.625 meters square, that is 58.875 meters square. Now, the next problem says that a brooch is made with silver wire in the form of a circle with diameter equal to 35 mm. The wire is also used in making 5 diameters which divide the circle into 10 equal sectors as shown in the figure. Now, we have to find number 1, the total length of the silver wire required, and number 2, the area of each sector of the brooch. Now, we are given number of diameters equal to 5, length of the diameter equal to 35 mm, and therefore radius will be equal to 35 by 2 mm since वो diameter का half होता है. Now, for the first part of the problem, total length of silver wire required will be equal to circumference of the circle plus length of the 5 diameters, which is equal to 2 pi r plus 5 into 35. So, this gives us 2 into 22 by 7 into 35 by 2 plus 175 mm, that is equal to 185 mm. Now, for the second part of the problem, number of sectors is equal to 10. So, area of each sector will be equal to total area divided by number of sectors. So, total area is equal to pi r square, which is 22 by 7 into 35 by 2 ka whole square, that is equal to 1925 by 2 mm square. Therefore, area of each sector will be 1925 by 2 into 1 by 10, that is 385 by 4 mm square. Now, the next problem says that an umbrella has 8 ribs which are equally spaced, as you can see in the figure. So assuming that umbrella to be a flat circle of radius 45 centimeters, we have to find the area between the two consecutive ribs of the umbrella. So again basically ये question यही बोलता है कि हमें area of the sector निकालना है. Now number of ribs in the umbrella is equal to 8. Radius of umbrella while flat will be equal to 45 centimeter. So area between the two consecutive ribs of the umbrella will be equal to total area divided by number of ribs. So total area will be equal to pi r square, that is 22 by 7 into 45 square, which is 6364.29 centimeter square. Therefore area between the two consecutive ribs will be 6364.29 divided by 8 centimeter square, that is 795.5 centimeter square. So friends, this is it for this session. We solved some problems concerning area of sectors and segments. I hope you enjoyed learning. We shall continue our journey in the next session. For any information or queries, you may visit the link following the video. Thank you.